Normally when we've been solving trig equations, we've said find solutions between usually 0 and 360, but they say between certain values. To generalize it is just to come up, I guess, with a formula where you can substitute numbers in and create as many solutions as you would like. So let's do it. Sine theta is equal to x. We're not going to restrict ourselves now between 0 and 360. Well, there's two possibilities, because if x is positive, we're going to get different answers to if x is negative. So if I look at when x is positive, now, the obvious answer is just inverse sine of x, but that clearly would just be the first quadrant answer, because x is positive. But if it's also positive, I'd be in the second quadrant, and the acute angle would be inverse sine of x. So my two possibilities then are inverse sine of x or pi minus the inverse sine of x. Okay, but what if it's negative? If it's negative, the acute angle now is not going to be the inverse sine of x. It's going to be the inverse sine of negative x, because x is a negative number. And to find the acute angle, I need a positive number. So in the third quadrant, that acute angle would be the inverse sine of negative x. Same as in the fourth quadrant, it would be the inverse sine of negative x. So my two possibilities now are pi plus the inverse sine of negative x, or 2 pi minus the inverse sine of negative x. But the inverse sine of negative x, we know, is an odd function. So inverse sine negative x is the same as negative inverse sine x. So I could rewrite that and get pi minus the inverse sine of x, or 2 pi plus the inverse sine of x. And if you think about it, really, we've got the same answers. See? The clear one to see is the pi minus inverse sine x. They're the same. But inverse sine x, 2 pi plus inverse sine x would be in the same position as well. So to generalize this, if I have an equation, sine theta equals x, then my solution to generalize it, I'm going to write it as pi k plus minus 1 to the power of k inverse sine x. So we go, you'll notice positive sine x, then negative sine x. Then when we got to 2 pi, it was positive sine x. So the plus minus is alternating. So that's why I've got the minus 1 to the power of k there. And then it's just multiples of pi for each solution. And so that should generate every possible answer that we need to find. Okay, let's have a look for cosine. So we'll do a similar thing. Well, if cosine's positive, difference now is we're talking about the first and the fourth quadrant. So the first quadrant, there's inverse cos x, and the fourth quadrant, so my solution would be inverse cos x, or 2 pi minus inverse cos x. Now, if x is less than 0, so second quadrant, third quadrant, inverse cos of negative x. Now, pi minus the inverse cos of negative x, or pi plus, but inverse cos of negative x was equal to, so it wasn't exactly an odd function, it was an odd function shifted up, pi on 2. So if we replace inverse cos of negative x with pi minus, we get inverse cos of x, or 2 pi minus inverse cos of x. Same answers. So again, it actually didn't matter whether it's positive or negative. So let's create a solution, a general solution for that one. If cos theta is equal to x, I'm going to say 2 pi k plus or minus inverse cos x. Because my next solution, if I was to do it, I would add 2 pi onto each of these. So I'm going inverse cos of x, 2 pi minus inverse cos of x. Then the next solution would be 2 pi plus the inverse cos of x, 4 pi minus inverse cos of x, then 4 pi plus. So we've got the 2 pi plus or minus the inverse cos of x. Well, let's see what happens with tan. Positive, first quadrant, third quadrant. So theta is inverse tan of x, or pi plus the inverse tan of x. If we make it negative, the acute angle now is inverse tan negative x, but we're in the second quadrant, or the fourth quadrant. So pi minus inverse tan negative x, or 2 pi minus. Inverse tan was an odd function. So inverse tan negative x could be...
Negative tan inverse x.
Yeah, correct, what he said. Negative inverse tan of x. So sub that in, we get pi plus. I think now this one is probably the easiest of all to pick up, because look at what we've got. Inverse tan of x, pi plus inverse tan of x, 2 pi plus inverse tan of x. So then the next one would be
3 pi plus.
3 pi plus. And so we've got our pattern there. So tan theta equals x is simply going to be pi k plus the inverse tan of x. Right, so we get a question like this. Sine theta is root 3 on 2, pretty standard sort of question, but this time they haven't said in between 0 and 360. So I'll go, okay, there's my general solution. Pi k plus negative 1 to the power of k, inverse sine of 3 on 2. Now I know what the inverse sine of root 3 on 2 is, so we'll write it as pi k plus minus 1 to the power of k on 3. Remember, at some point in your solution you need to specify that k is a whole number for this to work. Now, if they then said, oh, well, what is it between 0 and 2 pi, I don't need to redo the whole equation. I've now got a formula. And that's the whole point of generalising. It gives you a formula to use. So I'll sub in numbers. I'll sub in noughts, and I'll get naught plus pi on 3. Oh, okay, so I've got a solution pi on 3. I'll sub in 1, and I'll get pi minus pi on 3. Oh, that's 2 pi on 3. Sub in 2, I get 2 pi plus, well hang on, I'm going to stop straight there. Because if it's 2 pi plus, I don't need that one, because the answers were between 0 and 2 pi. So I've got my solutions. Let's do a cos 1. Negative 1 on root 2. So 2 pi k plus or minus the inverse cos of negative 1 on root 2. Inverse cos of negative 1 on root 2 is?
Negative pi on 4. Close.
3 pi on 4. Right? That has to give you the obtuse angle inverse cos. And that's actually quite important when it comes to general solutions. If you went negative pi on 4, it will actually create problems. So yeah, 2 pi k plus or minus 3 pi on 4. If we now want to work out between 0 and 2 pi, sorry, then sub in 0, I'll get plus or minus 3 pi on 4. Well, I don't want the minus 3 pi on 4, but I'll take the 3 pi on 4. Sub in 1, I get 2 pi plus or minus. Well, in this case, I don't want the plus, but I'll take the minus 3 pi on 4. And there's my two answers, 3 pi on 4, 5 pi on 4. All right, let's do a tan. 1 on root 3. Pi k plus inverse tan of 1 on root 3. Pi k plus pi on 6. And if we said, all right, let's find it between 0 and 2 pi. If I sub in 0, I'll get pi on 6. Sub in 1, pi plus pi on 6. Sub in 2, 2 pi plus, well again, I'll stop because I know I'm not going over. Pi k plus minus 1 to the power of k, the inverse sine of 5 pi on 7. What is the inverse sine of sine 5 pi on 7?
2 pi on 7.
Thus, getting our solution. So, inverse cos 2x equals 2 pi k plus minus. Inverse cos pi on 9. Divide both sides by 2. All right. Enough fun and games. Now we'll have much fun and games as we do them.